Hello, today my name is David and today we're going to talk about structures, functions and arrays. So what we have here is a structure created for employee. In this in this program we're going to look about two main things: how to use structures and functions. Here we have a structure named employee which has four types of variables in it, four types of variables: employee ID, name and salary and the designation. So what we ask the user here is to enter the number of employees in his or her company. Maximum limit for that would be 100. Depending upon the requirement, you can increase it or decrease it. Next step would be asking the user for the employee ID, the name and the designation. The later part would be asking if he or she is the manager or system administrator, depending on which we have two cases. Case 1 would be if you are a manager, your salary mainly would be 89,000, and when it is passed on to a function named manager, it moves down and comes here where your int x stores where your int x stores the total salary you've been allotted. And here you have different allowances and the ways to calculate for it. Then it returns total salary of that manager to the salary which is stored in the employee structure here in salary. And then when case 2 system administrator is chosen, the same process happens but with different numbers. And then later on, getting all the information, we print it using for loop again. Now for checking the program's execution and running, we compile it, and then we ask the user for then we ask the person to enter the number of employees in his or her company. For example, we take here 2. Then we ask for the employee ID, 1 2 3, name, then choose the designation. I've chosen manager. Employee ID again, the name, then now we choose system administrator. Then we get the following output: employee ID of 1 is 123, then name is David, and salary and designation as manager. Employee ID, name, salary and designation. This is for structures and functions. And now we have another program which determines the area of circle, rectangle, square and a triangle. But for this we have used function overloading. How this works is we give the same function name but with different arguments passed into it, each not having the same type of argument the same number of times, where that would cause an error. So what we have here now is we have given the user to choose one of the shapes, and according to the shapes we've asked him to enter the radius, the length and breadth, or the side or the three sides. So what we have here is when he enters the radius, it goes to the function area r passed to float r. So what we have here is calculation for area and the perimeter. Then for case 2 we have the rectangle part, and accordingly we have the calculation for it. Then later on we have the circle, and later on we have the area and perimeter of the triangle. So here what actually the program is all about is function overloading of a particular function named called area. Now for checking out the output of the program, we compile it and run. Now selecting a shape, first one circle, enter the radius of the circle, for example 5. The area is 70 the area is 78.5 and this perimeter is 31.4. Now entering y for rectangle, width, and entering the length and width 4 and 5. the area is 20, perimeter is 18. Now for square, side of a square is, for example, 6, area is 34, perimeter is 20, 36 and 24. And now for the triangle, we have three sides of the triangle as 7, 8 and 10. So this is the area and the perimeter of the triangle. Now I enter no and come out of the program. Now for our next program, we as known as Fibonacci series. In this we are actually focusing on recursion of a function. So what here happens here is we ask the user to enter the number of numbers to be printed in the series. Uh, this program here is the program here we are talking about has first three numbers as 0, 0 and 1. Later on we add all the three and print it as the fourth. So we get 1 after that. Later on we take 0, 1, 1 and add all those three and print the next. Here Fibonacci is declared for the function giving int first, int second and int third and int num. Num here is the total number of numbers to be printed, and we check for the condition if num is greater than or equal to 2, because we already know the first two values of the series, so we need not print those, so we subtract it from the total number of numbers. And then we print the third as we initialize z is equal to 1, where z is passed on to the function using arguments, and then we add all of them and initialize it to the first, because we won't be requiring first in the first place for the inside Fibonacci function. It will first will come into the last part, the second moves on and the third moves on. After that has happened, we decrement num by 1. And now for the execution of the program, we compile it and run it. Suppose the number of series to be printed is 7. I get 0, 1, 1, 0, 1, 1 are the first three numbers. Adding 1 and 1 we get 2. On adding 1, 1, 2 we get 4. And for later one, adding 1, 2, 4 we get 7. Adding 1, 2, 4 and 7 we get 13. So this is the primary focus on Fibonacci series. Later we have a program for adding and subtracting of 3D vectors. Here we have a structure named vector which has int num as its variables inside, and we have two vector declarations, and we have a main function. In this main function we initialize the variables sum 1, 2 and 3 as 0, and then using a for loop we ask the magnitude of the vectors v1, v2. Here we ask the magnitude of the vector v1 initially and then v2, and then we sum all of that into sum 1, 2 and 3. And later on we print all the added sum. Then we come down, later on we have the subtraction for the 3D vectors and we print the same. Now for checking the output of the program, we first compile it and then run. So the magnitude of vector 1 along x axis is, for example, say 4, along y axis is 6, z axis is 5. Now for magnitude of vector 2 along x axis is 7, along y axis is 1, along z axis is 9. Then we have the sum of the magnitude of vector v1 plus v2 along x axis is 11, along y is 7 and along z is 14. In the same way we have the difference in z axis is minus 3, y axis is 5 and z axis is minus 4. That's all for this part of the exercise, and hope all of you understood, and thank you.